Well, welcome everybody. This is Nalini Elkins with Industry Network Technology Council. I hope you can all hear me okay. Please let me know if you have any problems at all. This webinar is being recorded and we will make it available on YouTube afterwards. So please go ahead and send me a chat message if you, or raise your hand if you have any comments or questions during the session. So I am the president of Industry Network Technology Council, also founder of a couple of startups. And as I said, I've been involved in this whole area of IPv6 for a long time, and probably for the last 6 or 7 years, maybe longer. I've been very involved with the security area, mostly TLS and then MLS, as we're going to talk about today. So what is this whole thing, this MLS? That's what we'll talk about in the beginning, and then we'll look at the charter of the group, because that'll help us kind of put the whole thing in context about why we did it and what the basic idea is. And then we'll talk about why one of the big things that's important about MLS is the scalability, in particular the cryptographic scalability, which is done by using ratchet or Merkle trees. And then we'll go through a little example of how you might see this in an enterprise setting. So, okay. So let's look at why MLS was started and what is the need for it. So MLS is a cryptographic specification. It is also how do I say? There's a packet specification also, but not the actual layout of the packets. If you mean, it's called an abstract protocol. So what the point is that this is a layer that messaging applications can use. Messaging applications are such as WhatsApp and so forth, or you can use it in another context. In any context where you need group key establishment, and a group is anything, it can be a one-person group or a two-person group. Often it's thought of as more than a two-person group, because if you had just two parties, why not use TLS or SSH or something like that? So these are the basic properties of MLS. Let's go through them and see what they all mean. So the properties are confidentiality, of course. MLS provides end-to-end encryption. So the idea is nobody who is outside the group can read the messages of the group. That's as one might expect. The point of end-to-end encryption is also that the message server can't read the messages either, and so that's a large point. It's only people who are in the group can see it, and so let's think about how this is going to play out. If you mean confidentiality, that generally in the security area, that means you're going to do encryption. So how exactly are you going to set up encryption? Generally, we use what's called public key encryption, or the PKI infrastructure. Exactly how is that to be done? We might be familiar with PKI as it's done in TLS, but TLS is a two-party protocol. So here we have a multi-party protocol. So we've got to have some things that are different when we're dealing with a number of parties rather than two parties. Are we going to have certificates? What kind of certificates? Or some kind of authentication. Yeah, how are we going to do that? So So in terms of message integrity and authentication, that is something else MLS wishes to have. That is, that the message has been sent by someone who is authorized to send it. So anytime you see authentication, you're thinking, well, okay, so I've got to have some kind of credential. Oftentimes that's a certificate or some way of saying, I am really the person that sent this message. How do we know that? How do we get it to everyone? And the other thing, of course, is that it hasn't been tampered with, so that you don't have someone else changing that message. So here we then come. It's like, okay, well, who exactly is going to authenticate? Again, is it certificates? Is there a procedure? Who's going to sign the certificate? How do I know that that the certificate I have is valid? And then if you get to integrity, what exactly is tampered? You know, is it that you know, checksum, a regular TCP or UDP checksum will guarantee integrity? Do we mean something more than that? And then what exactly happens if there is tampering? Is there a fraud alert? What is that up to the application to do? What exactly happens? So the other thing is membership authentication. That means that everyone who's in the group can verify who else is in the group. This is a very important thing. You might not immediately see why this is necessary or desirable, but really the point of this is so that you don't have, quote unquote, hidden members. So you don't have someone else who's listening in or lurking that you don't know about. And this has, of course, benefits and possibly flaws. For example, if you have a message group between Mr. Terrorist number 1 and Mr. Terrorist numbers 3 and 4, then you may wish to have, or if you're law enforcement or government, you may wish to have a hidden member in that group. And that's certainly fair enough, but that is not something MLS allows for in this context. Another potentially less controversial person in the group is if you have a banking system and you wish to have the trades, the stock trades or banking stuff authenticated, that can validly be done within the context of MLS. Because a lot of times when you call your bank to make a transfer or someone else, a financial agency, you'll see a message on the phone call that says this phone call is being monitored and recorded for future service or whatever it is that they say. But that means that you have been given notice that there is someone else on the call other than you and the bank. There is a third party. That's perfectly valid within MLS. You may have a third party which is validly listening in, as long as everyone knows that that is the case, which is true in many instances. Sometimes there's a requirement, for example, for stock trades to be recorded. But then the question is, if you're going to see who else is in the group, how exactly are we going to do that? And who's got this list of members? And can someone else hack in and see that list of members? And in certainly the Mr. Terrorist case that I gave, that might be something that is of importance, is that whoever it is gets access to that list. and how can that happen? The other question that becomes interesting in this arena is who exactly can add and remove members? Can anyone add and remove members? Can someone add themselves without being invited by the group? How does this work? You may recall things like Zoom bombing, where I believe someone else who's not a part of your group joins in. I hope I have that terminology correct, but I think you see what I'm trying to say here. Yeah, so that's an important thing. Who is in the group? How are they added? These are all the things that MLS needs to address. So another interesting aspect is that keys can be established without anyone else, without everyone else being online. That would be quite onerous if you're starting a messaging group, say on WhatsApp or another messaging app, and everyone had to be online at the same time. So, but if you're not going to do that, then how exactly are we going to do it? And then are we storing these keys somewhere? Because clearly there has to be a participant then who's holding on to these keys. And so then how do we keep that secure? What happens if someone gets into that? Who's holding on to this a particular set of keys? And then, excuse me, how do we make sure that it's associated with each participant correctly? Yeah, because you can see what might happen if whoever is keeping that list and has the associations, if that is tampered with, then all bets are off. That is the technical term for that particular event. So, as far as cryptography, MLS offers both forward and post-compromise secrecy. So let's talk about that a bit. So forward secrecy, you might be familiar with that in the TLS context, is that if a particular node is compromised at any one time, and one of the message participants, that doesn't mean that all the past messages are also compromised. So how are we going to do this? In TLS, we do it by having essentially session keys, ephemeral session keys. So you have a session key per session. It lasts for the length of that duration of that session. It may even be rekeyed if it's a long-lasting session, and that session is not done afterwards. How are we going to do that? Because the protocols that TLS uses for doing this are for a two-party protocol. So how do we do it within a multi-party context? That's the biggest thing that we really need to think about, is this switches our head from a two-party protocol to a multi-party. And that creates a great many complications. So the same cryptographic methods can't be used. Yeah. But if we're going to use forward secrecy, that means that keys have to be rotated. But then, wait a minute. So if the keys are rotated, how do we make sure that everyone in the group also rotates their keys, so that someone in the group is not using an old key, and then no one can, and people can't read their messages, and he can't read other people's. So how is the synchronization to be done? And again, you can see how this list of keys is very, very critical, because if that's compromised, then we're in a lot of trouble. So post-compromise security, this is going the other way, is that if we compromise something, If a node is compromised, that doesn't mean that all future messages are also compromised. Again, how do we do this? How is this synchronized? The key rotation part, you'll see that a great deal of MLS has to do with this key establishment and key rotation. That's one of the key things that MLS provides. So now you might be asking yourself, well, messaging apps exist, and they've even end-to-end messaging apps exist, and so they figured all this out. So why the heck do we need MLS? Well, it's because of this particular thing. Well, there's a couple of reasons. One is scalability. Scalability is that the current messaging apps have limitations as to how big the group can get. And it has to, the reason why there's limitations is because of the underlying cryptographic underpinnings. Is depending on how you do the cryptography, the operations that are involved will scale at different rates. So one of the requirements for MLS is that as you scale the group, there's a less than sublinear scaling in the underlying cryptography. We'll talk about exactly what that means, because that's an important concept and really highlights the need for MLS. And so when we read this, you know, it's kind of funny. Every time I read the charter or one of these, or RF suits, sometimes even, you know, oftentimes if you can take one paragraph and in order to unpack it and really understand it, you need like 30 slides per paragraph to understand the concepts. So as I say that, well, that's how it is. So we'll talk about this and how this is, how this works. I'll give you some examples so you can see what the problem is and some potential solutions. Yeah, exactly. How do we do this kind of magic? And then you've got to have some limit. Well, what is that? And how is the scaling done if it's not sublinear? And then of course, what the heck is sublinear? So let's talk about a small sample of linear growth. So let's say that if you start at 25 and imagine that you're able to put some money aside. Let's just say $20 per week. So $20 per week is a constant amount, and hence that is linear growth. And so we use a linear growth model. What that really means is that linear growth grows by the same amount in each unit of time. If we take that to be for messaging groups, what that would mean is that every time you add a participant or a member to the group, it takes maybe 2 more operations. So let's say if you have 2 people, it takes 2 operations. If you have 3 people, it takes 3, and 4 people, 4. So then clearly there's got to be some kind of limit to this, because if you have 10,000 people in the group, you would have to have 10,000 operations. So that would not be a great thing. So you don't necessarily want to grow linearly. That's why they say we would like to grow at a sublinear. Every time we add somebody, we don't want to have to add an operation. So to carry out this example, so we're putting $20 under our mattress. And so at the end of the first year, we have $10.40. And then at the end of 40 years, you'll have 41,000. That may not, you may need more than that for your retirement. So hence, again, to get into other scalability, you probably wanting to do something like compound interest, which would be growing at an exponential rate. But certainly, that's not what you want for cryptographic operations in a messaging group. So you see, it's kind of what the problem is here. So this is one of the things that limits the growth of the group in other applications. For example, Signal is limiting it to 1,000. WhatsApp to 1024, although you can play some shenanigans and do some other things. They may, this is as of a few days ago, I looked up the latest numbers. They may be increasing all the time. But in any case, MLS can be, can go up to tens of thousands. If you have millions of participants, you could certainly have do topologies, something like what DNS does in terms of zones comes to mind. You could have that kind of thing, have different MLS clients participating. Certainly you could do that with WhatsApp or Signal also, but MLS is starting with a much higher degree of scalability. So that might be something that you want to do. And one thing I will say, many people who do messaging apps are very definitely transitioning to MLS. So this will become quite important in the future. Also, MLS and the whole ratchet tree, binary tree, Merkle tree structure is being used in other areas as well. In fact, there's a proposal for doing certificates, in particular post-quantum certificates using Merkle trees. If you go up to the TLS group drafts, you can see that. I believe it was submitted by Google. So this, a lot of the ideas that you'll hear in MLS are being adopted in other protocols. So what the heck is this whole thing with ratchet trees? What's a ratchet tree, and what the heck is a Merkle tree? So let's talk. A Merkle tree, it's a hash tree. So essentially you can hash some piece of information. Say, you hash your name. Say my name is Nalini, and I hash that to be 4. Your name is Andrew, that comes out to be 12, something like that. So you hash a small thing that symbolizes whatever that thing is, and you have a hash of trees. You'll see this is a binary tree. So each node has 2 leaves, so hence binary. You can't have 3 because I've never heard of a quantum Merkle tree, but that is kind of interesting because a byte or a bit has only the value 0 or 1, and so if you have a binary tree, you can only have 2 leaves. So that is a Merkle tree. So why that is valuable is that it essentially operates by being able to use a binary search. And a binary search is a very efficient way of doing things in computer science. So let's say we have a sorted list of elements, say 2, 3, 4, 5, 6, so on, and we want to find the number 7 within that list. So what we do is we divide the list. We do it by taking the middle one, which is 6, and we divide it in 2, hence the whole idea of binary. So if we divide it in the middle and we see 6, we say, oh, I see, we're looking for something that's 7. So immediately we've eliminated this first half. If we only have to look at the last half. If we're doing a sequential search, we'd have to say, is it the first one? 2? No. Is it 3? No. 5, 4, 5, 6. And if you have a very short list, why not do sequential? Because certainly there's code involved in doing a binary search. So you could just do a sequential search. But if you have a large list, doing something like a binary search becomes very, very efficient. So you keep going again. So you know it's in the second half, divide that in half, and then you do that. And you repeat until you see. So it's a very efficient way of sorting the list. And if you have a binary search, you can see how a binary or Merkle tree would become very important in being able to do efficient algorithms. So if we're using a Merkle tree, a ratchet tree, binary tree, then you can use essentially binary searches to do that. And so that makes the searching algorithms much, much faster. That's the whole idea about why people are doing this. They're storing information in binary trees. So what is that? It's a binary tree. You remember from the example I showed you of the Merkle tree that each node has 2 leaves and carry it on. So we've got 3 levels now. A is the parent of B and C. B is the parent of D and E, so on. And you refer to them as the left child and the right child, and A, the topmost, is called the root node. So you can see, and you can see how you navigate the tree all the way up to the root. And that is one of the essential cryptographic advancements underlying MLS, is the speed of searching, because many things, keys, identities, and so on, are stored in a ratchet tree, and that makes the searching of the algorithm much, much quicker. I'm glossing over things a bit. You might note that the MLS architecture is probably close on 60 pages and the protocol equivalently. So I'm reducing that down to the overall concepts that make MLS important. But because obviously how you create the leaf nodes, how you get information in and out, is a major part of the protocol definition. But you see how the underlying framework of using binary trees and the concepts of searching within that to store makes things much faster. And that is why MLS is able to support groups that are so much larger than the other protocols. But you're thinking to yourself too, well, sure, but I mean, WhatsApp, Signal, and so forth, they've been doing this for a while, and maybe I don't need groups that are more than 1,000 people. But another large problem is that, well, a problem to some people, I suppose, is that if you're on WhatsApp, you can't really talk to someone who's using Telegram or Snapchat or whatever. And, you know, it's an interesting question whether that's desirable or not. But it is interoperability within this context. It is something that MLS is working towards, is if we can use the same structure, then we may be able to federate or interoperate. But there's more to it. There's more to it than that. One thing is that if everybody is doing their own cryptographic mechanism, then how do we know they're valid? You know, it's one person said, and what's the security proof that says that it's valid? And so if we all congregate on one cryptographic protocol that is validated and standardized at the IETF, and quite a few people have been doing security proof of various parts of MLS as the protocol develops, just as they did with TLS. And that makes it very, very strong, so that each vendor or each developer of a messaging application doesn't need to try to do this all themselves, and everybody trusts that we're using this same cryptographic protocol underneath, and it has been validated by people. So that gives you much more guarantee that this is a valid cryptographic protocol. There is more, again, there's another layer to this whole interoperability thing, though, is that if you really want to do interoperability, you need for the actual packet or message format to be the same, or at least interoperable in some way. And MLS is what's called an abstract protocol. And what that means is that the definition of what is going out over the wire is not defined. It just says you need to have a welcome message, you need to have a commit message, and the commit message needs to have this, 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 and this. And that's very, very clearly specified. But how that is to be done over the wire is not defined. And so then we have to have something else that defines it. Otherwise, we're not going to be able to interoperate. And hence, there is a new working group, MIMI, More Instant Messaging Interoperability, and that is what is working on making things like the messaging services interoperable. That's another whole area of operations. There's another 3 hours of talking. You may wish to join these groups, MLS and MIMI, to see what is going on there. There are implementations of MLS, again, and this is cryptographic interoperability. And you can see that there are quite a few that are out there. And you can see people like Wicker. They're a large company and they have a proprietary implementation. I've used MLSPP a great deal. I believe Richard Barnes of Cisco did that one. Yeah, so you can, these are open. I'm going to take a look at what's in Bouncy Castle once I get a moment free. Yeah. So let's talk a little bit about the structure of how MLS is. In MLS, basically you have two things as far as the end user is concerned. You have a client who may be referred to as a member or a participant, and you have a group. And of course, the group can be from anywhere from 2 to tens of thousands. Each user could, of course, have multiple clients. You know, you can have you've got 2, 3 laptops, your phones, whatever. You know, we think that's normal to us to have numbers of clients. The two big components as far as management of keys are two things. You have an authentication service and a delivery service. And we'll talk about how these work going on now. But you could have, there's not a huge amount of definition of what the AS should have within the protocol. There's more. I believe I know people are working on some more definitions of what the AS should really be. There is more definition of what the DS can and can't do. But in terms of implementation, they can be centralized, decentralized, combined. You know, you could have both of these in one, you could have them separated, all kinds of stuff, yeah, as might be imagined. So the AS, let's talk about that first. So if you think of the AS as, let's say you're using WhatsApp, something like that. When you initially sign up for WhatsApp, you give it your name, phone number, and so on. That's essentially registering with the AS, or authentication server. That's the entity that has your name, your user ID, your phone number, the connection about who it is that you are. But the AS has some very large responsibilities. It is going to bind your information with the keys and then sign it. And because the signing it, the AS says, I give you my word that this is valid. So this is a very big task for the AS to do, is to say, I'm gonna, stand behind anything that goes on. You can see clearly that if something were to happen to the AS, we would be in very big trouble. Again, a technical term. So this is one of the key items, is that if something happens, if there's a fraudulent AS, basically all bets are off. So this, you have to make sure it's very, very secure. And that is left to the application to do, which I think is fair enough. There are many cases where the AS might be compromised, but this is one of the essentials, is you want to make sure that the AS is legitimate and not compromised. So what does the DS do then? Well, so if you've got messages, something's got to hold it and then send it off when other people come online. And so that's what the DS does. You send it a message and it says, okay, I see that you're in this group. I'm going to send this message to everybody else that is in your group. So it's holding the messages and it's broadcasting them. But another point of this whole scheme is that the DS itself cannot read said messages, hence the end-to-end encryption part. So let's take a quick look at how we might use MLS at an enterprise. Let's kind of walk through a sample messaging application. So let's do it as a play. So we've got these three actors. Let's say we've got these three actors. The authentication server, he's going to appear in the prologue and then go on. So it needn't come afterwards. The directory server or delivery server, he's in the prologue for storage of the key package, and then he is required henceforward. And the MLS client, he appears in that prologue for registering, but then basically AS leaves the story, and it is DS and MLS clients who carry on. So let's start. So let's say we've got this kind of topology. We have these four clients. We've got our authentication server, and you have something which is the delivery or directory server. So the first thing you want to do, this is, as I said, this is a sample application. You might have some kind of application where you have an administrator for this. And he logs on, he signs in. He may have an a multi-factor authentication token to do that. And so he'll set up and set the policies for everybody, how the clients are to be configured. There are choices of cipher suites. What are we going to do? So on. How many messages can you have queued up at any one time? How long do you keep these messages, and so on? All kinds of stuff. So you need some kind of administrator. So he's doing that. So let's say that you now have some MLS client. He wants to participate. So he registers with this authentication server. So the client is going to create the private keys according to whatever cipher suite that you picked. You create yourself an identity within the context of MLS. Say your user number 1234. You get some kind of credential or certificate, and then the AS signs that certificate. So what you've got here is that you've got something saying that this certificate is valid and it's bound to this client, and I, this AS, have signed it. And so you can see if you just blindly set up a fake AS, the signature is not going to match what the AS has done. And so you can see how that's one thing is if you just set up a fake AS blindly, that you're going to get caught for that. There's, of course, more sophisticated methodology, but that one thing, the signing, is very, very key. You know, I tell you, one of the things about MLS that super confused me in the very beginning is all the different kinds of keys that they have. They have the private keys for encryption. They have the signing keys from the AS. As I say, it made my head hurt. So the second thing then you do is after you've signed up with the AS, you also sign up with the delivery server. And that delivery server also has the capabilities for each client. You say, I can do, you know, I can handle these kind of cipher suites. I can take this many messages and so on. And the administrator does all that. And then this uses the HPKE protocol to do all this. HPKE under the suite. You can. That's again explaining HPKE is another 2-hour webinar. So I'll just leave that as said. And then you create something that's called a key package. You do a key package and store it at the delivery server. The delivery server, remember, it's signed by the AS. Now, Mr. Delivery Server has all this. He's got your private key, credential, and so forth. So when you finally go to start a group, that all the stuff I showed you was in the beginning. And then AS, DS, everybody is sitting there holding on to either key packages, authentication material, and so on. So then when you go to start a group, the MLS client, he's going to create a whole new group. He says, okay, I want to have a group. I want to have my friends Bob, Jane, and Mary in this. And so I'm going to start a whole new ratchet tree for this. Remember the binary tree. Each group is represented as a ratchet tree or a binary tree. So you can see how there can be very quick and efficient searching of that tree. And so there's a bunch of stuff that's stored within that. So that's the first thing that happens when the group starts. And when you add clients, you say, I want to add Alice. I'll download the key package from Mr. Delivery Server and add it. And then this whole stuff, the ratchet tree updates. And that is how this whole ratchet tree concept and updating of it, that's the essential part of how things are kept secure, how post-compromise and forward security is ensured, because new keys are generated all the time and the ratchet tree is updated. As I say, that's the essence of it. It's somewhat easy to explain after talking for 45 minutes, but in order to really implement it, I've done a sample MLS application, and I'm going to say I worked on it on and off probably for about 2 years. It is not trivial. So many things can go wrong. You could have a fake AS, fake DS, fake client, lots and lots of things. So in a real application, these are the things that need to be taken care of. And a bunch of this stuff is taken care of at the implementation layer rather than the cryptographic. So as you can see, there's multiple layers in this. One is the cryptographic underpinnings, which is what we've talked about. Then there's the packet formats that are on the wire. And then number 3, within an application itself, you've got to handle things right, like fraud alerts, fake messages, people coming into the group that are not allowed, and so on. As I say, this is very much of an introduction to what this whole business with MLS is. Let me talk to answer some of these questions. Oh, this is interesting. Okay, so there's a question here. I'll go backwards. Why do we need this when there's XMPP, open, decentralized, and so on? Yes. That is. I think. I think there are a lot of open, decentralized, and group methodologies. I mean, there are a lot of these things that are out there. Again, I think it's because the interoperability aspect, and then a lot of these ones, they do not have the cryptographic underpinnings validated as those in MLS are. And it does go back to group size. Yeah, so I hope I'm answering that correctly. So then there's a question about what is a double ratchet tree. Yeah, so you know what, I'm gonna leave that for, that's another whole section unto itself. It's essentially you can have there's quite a few permutations, asynchronous ratchet trees, double ratchet trees, and so on. There's quite a few permutations of the whole ratchet tree business. What else? That's basically, let me see if so let me see what else. Okay, so I have another question. Do the directory servers act as relays? Yes, that's essentially the point. The directory servers act as relays. They're not sending point to point. The directory server or the delivery server is a broadcaster. That's a broadcasting of the traffic, because you can see how you don't want to ask somebody point to point. That really wouldn't work. Okay, so great. Thank you so much for your time. And this is the last of the security webinars for this year. We will have one more, which is the IPv6 and CDN webinar, and that will be coming up soon. So thank you so much, and you will have a link to the recording and the foils. So please feel free to contact me with any questions or thoughts that you have offline. Thanks so much.